In the late 1600s, Newton proposed the three basic laws of motion. Newton's first law, also known as the law of inertia, states that an object at rest will remain at rest if they're at rest. Objects in motion will stay in motion with the same velocity unless acted upon by an unbalanced force. In short, objects will keep doing what they're doing unless force is applied to them. For example, Andrew will not move away from the computer until a force acts on him.
Andrew, dude, throw away your trash, man.
Hold on, fine.
What? I'm telling you, I'm just, dude, don't. Oh,
Yeah,
what the
heck?
Yeah.
Brian acted as the force, making Andrew move. Notice that the trash on the desk also won't move unless force is applied.
Fine, pick up the freaking trash.
Andrew applies the force to the paper to be thrown away in the trash. This law also explains why you move forward when the car suddenly stops. Pretend that Brian and Andrew are in a car. Notice the difference when Brian wears a seatbelt and Andrew does not.
Oh yeah, dude, I love this song. Okay. Oh!
When the car stopped, inertia kept them moving forward, causing Andrew to fly off his seat. Newton's second law states that the greater the mass of the object, the greater the force needed to accelerate it. This relationship can be expressed with the formula F equals ma, where F equals force, m equals mass, and a is acceleration. For example, Andrew is applying force to accelerate me on the chair. However, now that I am playing the guitar, it adds more mass on the chair, which means Andrew needs to apply more force to accelerate the chair. Now in this example, Brian is trying to apply force on the pencil to pull it towards him or lift it. More or less, the pencil weighs about 5 grams.
Come on, 2 more. Come on, you got this. You got this! You got this! You got this! Oh, okay.
Next, he tries to lift a dumbbell which weighs about 1.5 kilograms. He now needs to apply a greater force to lift the dumbbell than the pencil because it has greater mass. He isn't able to do this, which means he doesn't have enough force to lift it, meaning he's weak. Just kidding. Newton's third law states that for every action, there is an equal but opposite reaction. When dribbling the ball, the action is that Andrew applies force and his hand pushes the ball downward, the reaction being the ball pushing Andrew's hand upward. Next, this picture explains why a balloon moves up when the air comes out. The action is the air coming out while the reaction is the balloon moving up. The forces do not cancel each other out because the force is acting on two different objects, the surroundings and on the balloon itself. Hence, this proves the third law of action and reaction. These three laws of motion help us to understand how objects behave when they are at rest, in motion, and when forces are acted upon them. They explain the motion involved in any given situations that happen in our daily lives.